In this video, we're going to look at question 10 to 15, 2017, paper 1, starting with indices. Write each of the following in the form 2 to the power of n. You're told L is an n is an element of Q. Well, let's do the questions first, and then, as I tell you, let's see is this relevant if we need it. So, what's the rule for multiplying indices? It's that we add. Show the examiner what you're doing. 2 to the power of 3 plus 5 plus 10 is equal to 2 to the power of 18. Don't just write the answer down. You can see you've got loads of time. We need the modulus 2 to the power of 8 is equal to 2 to the power of 3. If you write that down individually, then we have 8, 2 to the power of 3 to the power of 25. A power to a power, another rule, is a multiply. So 2 to the power of 3 times 25. You're showing each stage is equal to 2 to the power of 75. And then the square root of 8. Square root of 8 is equal to 2 to the power of 3. And square root is equal to something to the power of a half. So we have 8, 2 to the power of 3. To the power of a half, and it's the same rule as part B. This is 2 to the power of 3 times a half is 3 over 2, and you can check this in the calculator and type in root 8 as well. And we did get a fraction in the last one, so Q did come into it, but it wasn't really relevant for the question. They gave full marks for 2 to the power of 1.5 as well, so don't be too worried about that. Question 11, dealing with linear sequence. So you should be thinking first difference same straight away. Second term is 40, and the sixth term is 16, 116. Fill in the boxes below to show the rest of the first 6 terms. Well, what have we between 40 and 116? This is kind of what we have here. We have a difference of 116 minus 40. We have a difference of 76. How many jumps is that going to be? It's going to be 1, 2, 3, 4, and all these differences must be the same. So if we have 4 jumps and they total to 76, 76 divided by 4 would be, looks like 19 a jump. So let's have a look here. You may go wrong, but do your little work off to the side here. 40 with 19 would get us to 59. Add on 20, take away 1, 78, 97, and 116. This would work. So you can see a tiny bit of rough work here. So 59, 78, 97 works here. And then Orla is asked to write down a quadratic sequence, and she writes down the following: 5, 6, 9, 14, 22, 30, and 41. Exactly only one of the terms is incorrect. So you may have seen a previous video of mine where I wrote down a quadratic that wasn't a quadratic for you to try and spot. Well done if you did. So let's write down her sequence again. 5, 6, 9, 14. What are you thinking about quadratic sequences? You're thinking second difference is the same. So let's have a look. Do your loops. There's no rush. 5 to 6, 1. 6 to 9, 3. 9 to 14, 5. Looks consistently. The second difference is going to be 2. 14 to 22 is 8. That looks a bit dodgy. It should be 7. 22 to 30 is also 8. 30 to 41 is 11. So 1, 5, 7, 9, 11 would work, wouldn't it? So you should see the pattern is wrong at this point. So 1, 3, if this was a 7, 9, what would we have? We'd have 1, 4, 14 would jump to 21. and we wouldn't need need to change to 30. Obviously we can only change one term. 30 would stay the same, so that works for us. Change 22 to 21. So just write out what you would write out if it was a real quadratic sequence and see can you find the mistake. Question 12, dealing with factorization. If you're told to factorize it, we'll factorize. The only way to get n squared, there's no solving here, is n times n. The factors of 18, if you want to write them out, 18 times 1, you're thinking of the number 11. Let's see, can we get some things that will get to 11? 2 by 9, straight away. And then you're looking signs. Minus and a plus means they're both minus. All these things that you've practiced over and over again. Minus 2, minus 9. The good guys will multiply it out to show the examiner that in fact it does give exactly what was asked, n squared minus 11n plus 18. Not only do they do it for the examiner, they do it for themselves. They move on to the next part. Pretty confident that they're doing the right thing. 4-term factorization. wy minus y, take y out, that would leave w minus 1. If you've done this correctly, the second bracket will be the same. If you've practiced it, this is what you're going to do. What would I need to put in front of that second bracket to get the last two terms? Plus w is there, so it would have to be plus 1, and that would check, give a minus 1 as well. So we bring the y and the plus 1 together. They're both being multiplied by w minus 1. You could put a little box around it if you wanted, you don't have to. And then this is a pure calculator substitution question when you see find the value of down here. So just do it up here. Type into your calculator 5, use the fraction symbol. 3 times 4 is x minus 2, and then minus 7 over 6 times 4 minus 12. You're going to want to work this out manually probably as well, but type it into your calculator, see what you get. You're going to have 5 over 12 minus 2, minus 7 over 24 minus 12, and 5 over 10 minus 7 over 12 will give over 60 multiplied by the top one by 6. So that's going to be 30 over 60. Could probably simplify it actually to be 1 over 2, but however, minus 35 over 60. That's what I'm saying. I'm not going to try and simplify down and up, so that's going to give me minus 5 over 60. So a minus fraction in a junior cert, minus 1 over 12. Just be ready for something like this. That's the end of question 12. Until you get to 12 part D. Factorize and simplify. So what do you notice about this? You should notice difference of two squares on top. 2e times 2e gives 4e squared. 3 times 3 gives 9. 1 a plus, 1 a minus, the order not important. And the clue always in these questions, one of the bottom factors will have to be the same for it to simplify. So look at the bottom, it's 2e squared, has to be 2e times e. We want to get a minus 9, so we're looking at 3's on top, so these are going to be 3's as well, 3 and 3. And then how do we get a plus 3e in the middle? So we'd have 4e. Is this going to work for us? May not. 6e, 4e, it's 2 3's or 6e and 3e, write them down. Just trying to slow down a little bit, and then to get plus 3e, we'd need plus 6e minus 3e, so this one is the plus, this one is the minus, so you can see the 2e's minus 3's cancel, so rather than crossing them off, you can just write equals 2e plus 3 over e plus 3. part E of this question is what they absolutely love. If you haven't heard me mention box method before, you have been living in a cave. This is a box method question, even though it's dressed up as area like this, so we know how to set up our box method question. The first and last term of the cubic go inside the box. Doesn't have to be a perfect rectangle. My cubic, the first term, 2x cubed. If you haven't learned off this method, you're crazy, because it comes up at leaving cert as well. The linear x minus 3 goes here. The answer to the quadratic will go on top, which will be the answer to this question. So go and look at the videos on this if you haven't seen it. X into 2x cubed is 2x squared. You multiply the 2x squared by the minus 3 down here to give minus 6x squared. These two boxes give me my x squareds. We want minus 13 of them, so I need another minus 7x squareds. X then, this x into the minus 7x squared is minus 7x. Repeating the process, minus 7x by the minus 3 is plus 21x. And then we need 25x. In the diagonal boxes, we have 21. We need another 4x. And x again into 4x is plus 4. When we check our answer, is this plus 4 by this minus 3 equal to this minus 12? It is, so we know that we've done it correctly. So you would write down A is equal to 2, B is equal to minus 7, and C is equal to 4. And you move on to the next question. Happy in the knowledge you've gotten this one correct. Question 13, draw 3 different graphs. So if you can see this is linear, we just need 2 points on it, get them at the extremes of the domain. So putting minus 2 in for x will give us a value for y, somewhere along this line up the line here. And then putting 2 in for x will also give us a value for y, somewhere along this line here. So show the maths. Y is equal to, if x is minus 2, we get minus 2 minus 1, which is minus 3. And then stick it back in up here and put minus 2 minus 3 on your graph. You could call it the point A if you wanted. And then do the same for this point. Y would be equal to, when x is 2, we'd have 2 minus 1, which is equal to 1, 2, 1, will be here. If you want to get the y-intercept, you could say when x is equal to 0, if you wanted to get a third point, or just put your ruler on the graph. If x is equal to 0, y is equal to minus 1. So there's another point, 0, minus 1. Stick it in there. You can see that they do line up. You're going to have a ruler which will be more accurate than mine. The second function was a quadratic. I would recommend you put all the points in here, minus 2 all the way to 2. So let's do that. Minus 2, minus 1, 0, 1, and 2. You're working your way along the x-axis. Then using your calculator to give you the answers. And it should form what shape? N shape here, due to the minus x squared. You've practiced so many of these. So your calculator will see 2 minus, minus 2 squared. 2 minus is what you're going to put into your calculator, so you're going to write it down here. 2 minus, you're putting minus 1 in, and you're going 2 minus 0 squared. So just type all these in, don't rush it. 2 minus, then you're going to have 2 squared. And hopefully your calculator gives 2 minus 4 is minus 2, 2 minus 1 is 1, 2 minus 0 is 2, 2 minus 1 is 1, and 2 minus 4 is minus 2. You can see the pattern. Put your values in. Take your time. Double check before you start rushing to put them on the graph that they actually do form an N shape. So minus 2 minus 2, I just do little dots maybe. Minus 1, 1, 0, 2, 1, 1, You can see they match off the symmetry of quadratics, and 2 minus 2. So you can see now you're confident you're right, so you go back, do nice big dots. I'll show you the reason why. It gives you more margin of error when you're drawing the curve. So do the big dots first. You're going to do the top of the curve first, and you can see it's easy to get it to go through the dots when they're nice and big. And then just complete the graph, and full marks for this one. The third graph here, again, I would put all the points in, unless you're an absolute expert at drawing these. Just work your way along, take your time. You're thinking to yourself, we've loads of time to do this. They've asked us to draw graphs. This is giveaway marks. So on your calculator, you're going to get y being equal to 2 to the power of minus 2, 2 to the power of minus 1, type all these in, 2 to the power of 0, 2 to the power of 1, 2 to the power of 2. If we work our way backwards, we may see a pattern. 4, 2 to the power of 2, 2 to the power of 1 is 2, 2 to the power of 0 is 1. What's happening? We're dividing by 2 each time, just checking your calculator. 1 over 2, and 2 to the power of minus 2 is 1 over 2 to the power of 2, which is 1 over 4. So you can put it in decimals or fractions. 0.25, 0.5, 1, 2, and 4. Minus 2, 0.25. So what's happening with these graphs? They're coming down these exponentials and curving towards the x-axis, but never hitting it. These asymptotes. So minus 2, there's a half, 0.25 maybe, just about there. You're just trying to get it as accurately as possible, but again, big dots. Well, actually, you know what we'll do small dots to begin, like I said before. Small dot. And then 0.5 at minus 1, out there. 0, 1, out there. When x is 1, y is 2. You can see it climbing now. 2, 4 will be up here. So in fact, you can see the curve down through the point 0, 1 and towards the x-axis, and then just because we didn't get near it there, make your dot a bit bigger, or just redo the graph. But you shouldn't have to. You should be taking your time in the exam and doing a bit better than me. So question 14, the table below shows some information about regular polygons. You might get a bit confused already. These are shapes where all of the angles are the same size. So it looks like we have a triangle here and a square rectangle. And we're told the sum of the angles increase in a linear pattern. So now we're thinking, okay, this is a linear pattern question. Let's not worry about the polygon bit. So the sum of the angles increase in a linear pattern. Go back to the table. 180, 360, add 180, 540, add 180, 720. And then part C, the size of each angle must come into this question. We're obviously dividing 180 by 3. We're dividing 360 by 4. 90. I don't put them in too big. They look like zeros. 540 divided by 5 is 108. And 720 divided by 6 is 120. And then we are asked to complete the column in the table showing the sum of the angles. We've done that. And then find a formula for the sum of the angles in a regular polygon with n angles. And these values follow a linear pattern. So let's write out the pattern 180, 360, 540, and 720. And the key to this question is that the ends here are 3, 4, 5, and 6. So if we ignore the 3, 4, 5, and 6 just for a second, and we did just a linear pattern, we'd have the difference is 180. So we'd write 180n. Now let's look what's happening here. When n is equal to 3, it's the first part of the series, 180n would give 540. So we'd actually have to take away 360 to get back to the 180 at the beginning. Does that work for pattern 2? Would that give me 360? So it'll be 180 times 4. Sorry, 180 times 4 is 720 minus 360 is 360. And then for 5, 180 times 5 is 900 minus 360 is 540. So this is our pattern for the sum of the angles in a regular polygon with n angles. For part C, we've already filled in the size of the angle, and then D, the size of the angle we were just multiplying, we were just dividing part A by, we were dividing this guy by this guy, so it'll be this guy divided by n for part D, 180n minus 360 over n. And the last part, question 15, 3 curves are shown, and 2 of the curves show a function of x. We have this one here, we have this one here, we have this one here. Well, even by drawing this, it can't go back on itself. So the vertical line test would, if it has more than 2 values, can't be a function. So that must be what they're asking here. This can't be a function in x. Put a tick in the correct box to show which curve does not show a function of x. So let's see the reason vertical line test. If you know your vertical line test, or more than 1 value for y when x inputted. Something along these lines. Loads of correct answers here, but your knowledge of functions and these, what represent a function in x, very important here.